Hello, everyone. Welcome to the Open Planetary Lunch for April 6th, 2021. I'm Chase. Thank you all for being here. Our speakers today are Jordan Padams and Thomas Loubrieu. Sorry. From the Jet Propulsion Laboratory. They'll be talking on Intro to PDS API Specification, parentheses alpha version. And we have a big turnout today, so clearly a lot of people are very interested in this. Thank you both for being here, and when you are ready, just go ahead and take over the screen share.
Great, yeah, thanks, Chase. So, hello everyone. My name is Jordan Padams. I met, I think, most people on this call at some point. Tomas will be presenting a little bit later. And so we are, as Chase mentioned, we are both work at Jet Propulsion Laboratory in California. Well, not recently, mostly online at this point. We are I'm the node manager for the PDS engineering node, which is we're kind of responsible for the system engineering of the PDS. So most of you probably interact more closely with discipline nodes. And so we're kind of under the hood providing some of the infrastructure and backend services that provide access to the data. So anyway, that all being said, PDS API. So what I'm going to jump into here is just a quick overview of what we're going to talk about. So I'm going to give a quick background on where all this came from. So the history of this, what we are calling PDS Data Services project that we've been working towards over the last year or two that we started working on. Then we'll kind of dive into like an API. What can an API do for me? So that should be a 4. But so basically, how can an API be used and why does it matter? And then we'll also then talk about the PDS API working group that we have currently in action. We then have our specification and implementation that we'll walk through. Those last 2 items will be flipped, but then Tomas will take over, walk through a demo of how to use the API as it currently stands with Jupyter Notebooks. And then we'll talk about kind of our future plans, some that are near term and some that are longer term, just to kind of give folks an idea of where we're headed. Okay, there's data services. So back in 2019, the PDS decided that we needed to begin thinking about access to our data and discovery and use and analysis. So we came up with this vision statement, which is the PDS, we're looking towards providing an integrated worldwide data services platform that enables discovery, dissemination, use and analysis of planetary science data. So that's a long-winded sentence of saying, we're just trying to move our system to be as user-centric as possible and user-friendly as possible so that folks can do science faster and easier with PDS data. So here's more details about the vision. I won't go into this. I presented this at multiple places, and there's a link to a poster here as well. But basically, as I mentioned, we're just trying to move towards providing more access to our data and ability to search using consistent APIs, integrated search across the entire PDS, and then also moving beyond that into enabling ongoing exploration and integration of tools with the PDS for visualization and for use and analysis of the data. So here's a quick overview of the architecture for that data services project. So it's towards a planetary data ecosystem. So we'll get into, I'll walk through this in a minute. But the idea being that we're evolving this over time. So today we are focused on this stewardship model, which I'll talk about in a moment. The plan right now in a 2 to 5 year phase is to move towards search and access. So trying to enable this using things like extensions to our query models, APIs, search engine integration across the PDS, and then a revived front end for the entire PDS so that folks can actually utilize these services. Eventually, we can start to move more towards this analysis support, analytics, visualization tools, more of the, I guess, user-focused tools, but you can't have that without search and access to the data. So going back to our architecture, so as I mentioned, stewardship is pretty much this interface between the missions and the archives and data proposers in the archives. So it's our continued focus. That's what our job, that's our bread and butter, is we have to be an archive, right? Which means our data needs to be available to the public 24/7, and it needs to be usable well into the future. 50 years is our model. So that needs to be our focus, but we need to start thinking about how we can improve discoverability, accessibility, and usability of those archives. So this middle layer needs to be built out more across the entire system so that it's more consistent. And then once we have that in place, that enables the PDS and the community to then develop tools to enhance the usability of the data, which is really where we're trying to get to make it usable and easier to make discovery using that data. But the first thing we need is this well-documented, well-understood interfaces or search APIs so that you can actually get to the data easily and not have to worry about sifting through products, but actually be able to find what you need and use it right away versus having to spend all your time trying to find what you actually want. And then, as I mentioned, then we can move on to more tools and services that support the analysis, analytics, and usability of the data. So, okay, so what can an API do for me? So one way to think about this, so Tomas kind of came up with this kind of phrasing, but APIs provide the highways to drive users to the data. So thinking about, they have the exits, they have the signs, they have the traffic sometimes, they've got the clunkers clogging up the road, they've got all these different speed traps, all these capabilities, right, are built into APIs. So one way to think about it in that way is without an API, you're kind of just wandering off in the wild and you kind of have to just figure things out. APIs give you those structures, that highway to take you where you need to go. So thinking about how this then feeds into search across the PDS. So right now, this is kind of the picture of the PDS as it stands. And you can see that by everyone having their own API for their own search capabilities, we have many different roads and paths, some paved with clear signs, some backcountry dirt roads where you probably don't want to drive on that with a Tesla or any new car. So what we want to do is build this layer on top of all of these search and access tools, and even further into all of our tools, so that we have one highway, which is the PDS API, that has consistent signs, consistent directions, and we continue to it'll build over time. So the highway will get bigger, but we at least have a consistent one-stop shop for how to access data in the PDS. So one example of this is, say you're a Planetary Pi developer and you want to create a tool that includes searching for PDS data. So you can hopefully at some point utilize one method in order to search all these different archives, right? So, and all these different search tools. So you can actually loop them in all together, integrate them together, and then it's very consistent how you would communicate to a PDS archive or a PDS search tool, right? And so this is really from a programming perspective more than anything, but for folks trying to do analysis of data quickly using things like we'll talk about later, like Python scripts, this really helps make this seamless using just a client that's accessible to the PDS API. So that's the background, I guess, just a quick high-level overview of everything. I'm sure folks have questions, which we can get to later on, or feel free to interrupt me. I don't know how this usually goes. But yeah, so the background, we're headed in this direction where we need to enable search and access. So we needed to do something about that. We actually need to make action happen. So the PDS formed this API working group, and the intent was to provide the technical expertise and guidance to our management council and to the international community on this PDS API spec. We just needed to sit down and actually make it happen. And so we have a charter for the group, which is on Google Docs. And then we also have our API spec, which we started to put together, our alpha version. It's on a markdown in this repo on GitHub, and then it's also in development in Google Docs. So we'll talk more about those later, but yeah, these are open source repositories, all of it's online, and we're looking forward to feedback. But so yeah, we threw that together with the working group. Here's the working group. Thanks again to everyone for their help on the PDS so far, and also our European colleagues from ESA. And so, guys, a quick little overview of our goals and plans. So as I mentioned, the ambition behind this API is to build this layer that can allow users and systems to explore the PDS resources seamlessly. And as I mentioned, the highways that drive users to the data, which reside at the nodes, right? So it's just this trying to build this highway system. And we wanted to develop this PDS-wide API spec. We're focused right now on searching on collections of data, but as Thomas will show, searching for products is also possible using this API. And we're also in the process of developing libraries, clients, skeleton servers for setting up these APIs, and then a standard implementation which sits on top of our PDS registry, which we're in the process of deploying across the PDS. So I guess a quick, for folks who don't know what a web API request looks like, this is an example where you'd search for instance, this first get query, you just send a get request, and you can either do this via Python, or even if you put it in your browser, it'll return JSON in your browser. But you can see how you can search by some product with a lidvid, and that's kind of this first request. Or you can actually do some sort of search capability like collections search Europa, right? And we can actually provide some search mechanisms in the API in order to return your results. The result, very simple, just looks like JSON. Well, it's a little more complex as Thomas will show, but that's the basic premise of what a web API request looks like. So now that we have what a web API request looks like, we started actually building this out to various endpoints that we have online. So our API specification, the actual core documentation, as I mentioned, is online on GitHub and also on Google Docs. Right now we have various endpoints available that are for collections, bundles, and products. And they're all specified using an open API specification. So what you see on the right here is actually auto-generated by using our Swagger YAML file. And so that's kind of what you see over here on the right. And it's so we're using open API spec for this as well. You can see, some of the endpoints we have created are these lid resolvers or lid bid resolvers. So you put in a product and a lid bid, it'll return that metadata. Same with collections or bundles. They all pretty much sit on the same basic premise of behind the scenes. So yeah, one of the use cases that Thomas will show is this last bullet here is crawling an archive. So you can think about how you can start at a top level and search for bundles that are related to things you care about. And then you say, oh, okay, well, that actually gets me kind of where I want to go. I want to find those collections. And then you can find the products associated with those collections. So you can crawl the archive, browse it, or as you'd like, using this API. So yeah, the API implementation. So now that we have kind of the specification drawn out, we have this open API schema that we've defined. We now started to build some of those components that we talked about. So we have these reusable elementary components for this API. We have the automated documentation, which you can find on GitHub. We have a Postman a Postman tool that you can use in order to set up Postman and actually test and play around with the API. We have a query Lexer based on, if you go to some of the our specification document, it talks about our query syntax. And so that's where we have a Lexer in order to handle that. We also have a Java library, a skeleton server, a client, and some demonstration notebooks, which Thomas will be presenting. So, okay, that's a brief overview of kind of why we're even doing this, and kind of an overview of the components that we have. So I think now what I'll do is I'll hand this off to Thomas, who will actually walk through the more interesting part of this, which is an actual demo of the API in action.
Hello. Yeah, so I'm Thomas. So I work with Jordan in the engineering node. And so I will share my screen now. Okay. Okay. So yeah, I have a short slide of introduction for the demo. So for this demo, we choose what can be as close as possible to a scientific use case. So however, I'm not, my background is software engineering. It's not planetary science. So be nice with me when I talk of these things. So we chose, after a proposal of Kate Crombie, to work on OSIRIS-REx data, and specifically the OVIR instrument, which is a visible and infrared spectrometer. And so I will present you two notebooks, one to explore this collection of observations. So these are the spectrometer observation of this asteroid, Bennu. And I will have a second notebook where we actually visualize a subset of data. So all the material is available in a GitHub repository that you can go to whenever you want. So when you get this repository, you can have actually the same setup as I have here. And so I guess most of you are familiar with the Jupyter Lab. So that's what I started locally. And then I have these notebooks. So the first one to explore a collection, and the second one to find and visualize data. So I'm starting with the first one. So we try to make them as self-explanatory as possible so that anyone can come back to them and use them as a tutorial for the API. So how that works? So that's a Python notebook. There are some traditional or usual import. What is important regarding the API is that we import a library, a package, which is available on PyPy, and which enable to interact with the API without using the URL that Jordan showed before. Like, it's some kind of abstraction for the request we do, and also for the response you're getting from the API. So you will see that concretely after. Then we have a step where we need to configure the endpoint of the API we want to use. So far we're in a alpha development, like it's not stable yet. And so we're working with a demo server, which is the most stable server we have. But eventually this will be hidden from the user, like there will be a default production endpoint for the API. So now we have an API client configured. So for this use case, the idea is for the user to explore a collection. So what we are thinking is, sorry, I have the zoom on top of my tabs. So yeah, the idea that the user will search for a collection manually. So if you're familiar with the PDS website, there is a keyword search that you can use and search for something you like to explore. So in this case, I'm interested in OSIRIS-REx OVIR calibrated collection. I can search for it. I have multiple results, but this collection is the one I'm interested in. So there is this identifiers for PDS, which we call lead vid. So they include the identifier plus a version. So we can take the full identifier if we want to explore this collection, but we can also remove the version. And in this case, the API will take the latest of this version available on the server. And so then what I want to do is to have an idea of what properties, what fields are available I can search for in this collection. So a collection is a collection of different data products. And with this request, I will see what properties have these products have. And so not to get the data at first, I can use this option, only summary. And so I'm getting the list of fields I can request the dataset on, or the collection on. So now that I know what I can search for in this collection, I can actually get the data. So if I want to get the data, I don't necessarily want to get all the fields proposed, so I can select my properties of interest. It's what I'm doing here. I selected a few fields out of this list. So here I'm getting the latitude, longitude, and the target range. So for the instrument, it means where the instrument is measuring on the asteroid and the distance from the asteroid. And in this case, so the collection has I think that's a total 1 million products. And when I do this request, I only have 150,000 products. However, it takes, oh, sorry, no, that's almost 300,000 products. So it takes 12 minutes to get them. So we will not run that now. But I will just show you that. So for the RESTful to be efficient, we need to work with a paginated result, which means we cannot get all these results in a single request. We need to loop on pages. So that's what this loop does here. So again, I will not run it since it's more than 10 minutes. And so
hi.
Yeah.
I have a question. I don't understand fully what you mean by getting the products, because I don't see a save routine, or so what do you mean by getting the products?
Yeah, I mean getting the description of the product, not getting the data. Does that answer your question?
So you get some kind of text field that describes each product.
Yeah, so if you like, I will just jump to this next step. So I'm getting the list of the description of the products, these 300 products. So I can show you one of them.
Okay.
So that's what I'm getting.
Thanks, yeah.
So I'm getting something similar to the description that Jordan showed earlier. We have a few default attributes for the description, the ID especially, but description, some links to the investigations area, which is the mission, the observation system components, the start date, start time of the observation, the target, so beneath this asteroid, and a title and the type of product we're requesting. And here, since we subsetted the properties we're interested in with this argument, we're also getting in properties these fields specifically. So there are a lot more available for each of these products, but thanks to this argument, we are only getting these three attributes and the lead vid, the identifier. So now that I have that, it's a bit like some more boring cleaning. I just want to remove the field values since we're getting some products for which these values are not interested, like they are default values or they are not available. So I filter that out. So here is an example of what I'm getting now. I just have the ID and the location of the observation and the target range for each of the products. Now it's again some organization of the data. Instead of having this list of dictionaries, I'm having an array of latitude, an array of longitude, and an array of target range so that it's easier to plot. And now I can plot this data. So these are the locations of the product I requested, like the different products of this collection. And thanks to the description I pulled from the API, I'm able to plot where the observation were and the distance to the asteroid. So since I try to understand myself how this observation works, I also made an histogram of the target ranges to have a better idea the different phases, I guess, of the observation. So I realized that most of the data are observed closer than 4 kilometers of the target. I will go quickly because it's on that because it's not on the API, but it's just to have a concrete example. And so now I can filter. In this example, I will just get the data around a specific spot. So namely latitude 12 and longitude 24, and where the target range is closer than 4 kilometers. So I can do that from the array I got previously from the API. And so I'm taking the observation which are 3 degrees around the targeted location. And so I get 4 products that I can that I can explore deeper. So for example, for one product from the ID, I can use the API again and just get the full description of the product. So I'm using a different endpoint of the API through the this client library. So this is the endpoint which enabled to get the full description from the lead vid, from the identifier. And so I'm getting this one of the like this product, and I'm getting its full description. So there are a lot more information. So this description, for those of you or most of you, I guess, are familiar with the PDS4 label. All these information are coming from the PDS4 label. And so then what, I'm not sure if I will find that. So the idea that the user is then interested into getting the actual link to the data file. So this is this attribute that we can find something somewhere in the list of properties. So I can subset, just get the properties of the data file reference, and then I get this fits file available. So that's the end for the first part of the demo. And yeah, to show you how you can crawl through a collection and get information from the products inside. So now I will show you how to get data and especially to get a subset of data.
Sorry, Thomas, just wanted to I know I think we're going to hold off on full questions until the end, but just to make sure that, are there any just high level questions about what we were trying to accomplish there? We can dig into more details after we turn off the video, but want to make sure we're not too lost or people aren't too lost.
Yeah, if you want to interrupt, that's completely fine. If that will make the presentation more understandable, that's good. So then the second notebook is to access actually the data. You'll see this one is shorter actually. So the beginning of it is the same. We need this API client, this Python package. We connect to the same server. And now what I wanted to show you is that this same subset that we made in the previous notebook, we can actually do it directly by talking to the API. So one of the first activity of the working group was to define a query language to request the API. And so we implemented that. So a user can do some complex request by doing comparison using a Boolean operator and grouping them together. So so from that you can do an infinity of complex requests. So from an example that might be more understandable. In this case, so you remember I wanted the observation which were made closer than 4 kilometers. So I take this target range attribute and I want them lower than 4 kilometers. And I also want the observation to be like the latitude to be around 12 degree minus 3 degrees or plus 3 degrees, so greater or equal to 9 degrees and lower or equal to 15 degrees. And we want to do the same for the longitude. And so we have this criteria, this complex criteria that I can apply to the API with this command. So I'm searching for products. I want to subset the products with this criteria, and I'm only interested in these properties of interest. So it's the same as before, latitude, longitude, target range. And this time I added the link to the data file, which eventually I would be interested to explore. So I can run that. And so what's interesting, so I get the same for products, we can check that. So that the same 4 products that I was able to subset with the previous notebook, instead that this time I did not need to download or to get the description or even a subset of the description of all the 300,000 products. The API did that for me, and it did that quickly. So now I have these 4 products, they're lead. And if I want to get the data files, instead of using the ID of the product, I will get these properties that I talked about before, the link. And now I have the links, the 4 data files that are like the data related to these 4 products. And then that's easy. I guess that's easy because that fits data, and there is a very good library which enable to read these data files remotely. But I can loop on these 4 files and open them with, so it's part of AstroPy IO library. so I can read them and plot them. So in this case, I'm plotting this instrument as 4 dimensions. So if I understood well, but maybe some people can explain better than me here on the call. So this dimension is the length is 20, some kind of different detector. So I plot the same detector for the 4 observations on the same plot, and they look similar, which is not at all a scientific test, but at least a sanity test on the API, how it works. And so that's it for the second part of the demonstration, with the actual access to the data, and how this subsetting this query that the working group, this query syntax that the working group has defined, can help to go straight to the data a researcher can be interested in. Okay, so thank you for this part, for the demo. So again, yeah, the content is on this GitHub repository. And yeah, that's it for the demo. I don't know, Jordan, if you want to go on with the perspective just now.
Yeah, I'll finish up how about we do that? So I'll finish up the kind of where we're going, and then we can kind of loop back as folks come across questions or things. So yeah, let me pull up my slides here. All right, so coming soon. So what's up next? So near term, we're shooting for October 2021, is some performance improvements. So just some things under the hood with the API can become a lot more streamlined when we push a lot of the performance onto Elasticsearch, which is sitting behind there as the registry. So we're working towards that. That'll be part of October. We also just want to get more metadata and more data products into there, so that folks like this community can play around with it and really give us some good input. We also want to continue the development of these Jupyter notebooks. So community input, absolutely welcome. And we'll talk about those repositories and things later. But the whole point of this is open source. And so we want to make sure we get, people are aware of that. We also want to pilot an integration with some of the discipline node search engines. So depending on people's availability in the PDS, we're going to try to maybe pilot out a couple examples of that. We also then want to support this. So obviously this demo was PDS4 centric data. We want to look into at least designing how to support PDS3 databases that we have across the PDS. Also supplemental metadata. So like new, improved, machine learning tagging, that kind of thing that some of the nodes are doing. We want to be able to support that. And then also extend the API to include units. And so that's one thing we want to include there. Right now it's there, but it's kind of under the hood and it's not really documented well. So we need to make sure we do that. And then we're continue to refine the response format. So a lot of the comments which were in the chat are absolutely real great comments. I think we want to continue to improve what's returned and get those user stories. I think I just wrote one, improved another, and I'm in the process of writing a third while I was on this call. So I think it's fantastic. The more feedback we get, the better. Even if you I think I'll talk about in a minute how to input, but we want to refine this based on your input. That's why we're giving you an alpha. We're doing an alpha demo, is because that's really how we can get feedback from you, our community. So longer term, we're working on a web UI to access the API. We also have some search integration in general across the PDS, but then beyond that too, to extend to our international partners and then other APIs. So we want to start integrating, with PSA and PDAP API and EPN tap and continue to grow how we integrate over time. Like my diagrams earlier, that's really our ultimate goal here. We then want to start to look into some things like some predefined compute or analysis you can do on the fly. So things like mean, min, max, that kind of thing. What else? So some development of tools. We'd love for continuing to evolve the tools we have that access and utilize PDS data. And so we want to build tools to use the PDS API that integrate with the PDS API and then use data across the entire federation, not necessarily just at one individual node, but across the entire PDS. As I noted, the Jupyter notebooks, other data analysis capabilities, want to continue to grow that. And then future, if we remember one of my earlier slides, this evolution, right, is eventually then start build out more and more data services that integrate compute alongside the data. And so we're going to continue to do that, and then just integrate. So we want to continue to grow how the PDS API can integrate and work with not only the entire PDS at minimum, obviously, but to start to expand and integrate with APIs and things outside of our boundaries. So it's a future goal. We have, limited resources, but this is kind of where we're headed. So then last but not least, but getting involved. So, we'd love for folks to get involved and be, a part of this, moving this API forward. And so we have our PDS Slack channel on Open Planetary. Feel free to comment or raise issues there, or conversation. Conversations about the PDS API are self-documenting. So it's really great when people just ask questions. Same goes for the forum. The forum's even better because you can search on Google and it pops up, so that's great. We love things there. The next slide, we have several repos all over the place that we need to link together a little bit better, but for now, they're all out there. Feel free to submit feature requests, bug reports, anything. We're looking forward to that. And then also user stories. So we're looking for this user scenario. Let me go back here. This scenario that we got was from one of our users at Small Bodies Node, PSI, she's actually a mission personnel for OSIRIS-REx. She gave us this use case that was great. And that's a high level, just user scenario we can start to play around with. Even more detailed though is what we even saw in the chat are very specific functionality that you would like to see in the API. Things like, how do I get a distinct values for a particular field? I want to get the number of hits possible for those are great user stories. We want to make sure we have those captured and that we can prioritize them accordingly. So there's a couple avenues. We have, the stories you can submit using this feedback link. You can email or Slack myself, Tomas, or anybody that you know of that works for the PDS, and they'll get it to us, and we can continue to move forward there. And so finally, now last but not least, all of our artifacts that are in work. So as I think we linked to this before, but wanted to link to it one more time. All online, all open source. So please, feedback, welcome, and this will continue to grow moving forward. So